Okay, this is number 6 on the 2003 test. And part A asks us if f is continuous at x equals 3. So first, for that to be true, the limit as x goes to 3 of f of x has to equal f of 3. So first, let's check if the limit exists. So the limit as x goes to 3 on the right of f of x equals 5 minus 3, which equals 2. And then let's check the limit as x goes to 3 from the left of f of x, and that is the square root of 3 plus 1, which equals 2. So the limit exists. And then let's check what f of 3 is. F of 3 is the square root of 3 plus 1 equals 2. So, since f of 3 equals the limit as x goes to 3 of f of x, therefore, f is continuous at x equals 3. All right, now B. B asks us to find the average value of f of x on the closed interval from 0 to 5. So average value means the formula for average value is 1 over the distance of your interval, which is 5, times the integral from 0 to 5 of f of x. Now, f of x is a piecewise function, so we have to break it up. So we have 1/5 times our first integral, which is from 0 to 3 of the square root of x plus 1 dx, and then we add the integral from 3 to 5 of 5 minus x dx. So when we integrate, I'm actually going to do a u substitution here for my first integral. So u equals x plus 1 du equals 1, and I'm going to change my limits to 1 to 4. So once I integrate that, I get 1/5 times 2 over 3 u to the 3/2, because I would plug in u, it'd be u to the 1/2, and when you integrate that, you get that. Evaluated from 1 to 4, and then I add this, my second integral, which is 5x minus x squared over 2, evaluated from 3 to 5. And then you just plug in, do 1/5 times 2 over 3 times 4 to the 3/2 minus, it's going to be 1, or it's minus 2/3 times 1, so 3/2. And then I add 5 times 5 minus 5 quantity squared over 2. I will be subtracting 5 times 3 times 3 squared over 2. Okay, once you simplify that, you have 1/5 times 14/3. Actually, we'll skip steps. Times 16/3 minus 2/3 plus 25 minus 25/2 minus 15 minus 9/2. Okay. And that simplifies to 1/2 times 20/3, which simplifies to 4/3. Now part C. It says g of x is defined as k times the square root of x plus 1 from 0 to 3, and then mx plus 2 for 3 to 5. And it says k and m are constant, and it asks us to find the values of k and m if g is differentiable at x equals 3. Now, the fact that it's differentiable means that the derivative exists. So let's go ahead and take the derivative of g of x. So the first part, it's going to be 1/2 times k times x plus 1 to the negative 1/2. That's just the chain rule. And then the second part, it's just going to be m. Same limits, or I don't know what you call them. Okay? So now, what we want to do is I'm going to take the original function and solve for k, like plug 3 in and then solve for k. So k times the square root of 4, which is 2, equals 3m plus 2. So k equals 3/2 m plus 1. Oh, you're kidding me. Alright, now as we said, k equals, what does k equal? 3/2 m plus 1. Now we're also going to plug 3 into the derivative and solve for m. So 1/2 times, actually, 3 plus 1 to the negative 1/2 times k, and that equals m. So k times, what did I do? Okay, so let's solve for m. So 1/4 k equals m, and then we can just plug this in for k. So 1/4 times 3/2 m plus 1 equals m. 4m plus 4m, sorry, equals 3/2 m plus 1. M, 5 halves, subtract 3 halves from each side, 5 halves m equals 1. M equals 2/5. And then plug this back in for M here. Or plug this back in for M here. To solve for K, so 1/4 K equals 2/5. So K equals 8/5. And you're done.